I was the Executive General Manager for New South Wales when we tendered Windsor Bridge. And I'd obviously heard about the reputation that Rob Maltoni and the Mainline group had with our Amanda Bridge in West Australia. And they did a great job, and the Demolition, in actual fact, went on to win international awards with our crew. And so we obviously gave Rob a chance, or Mainline a chance to tender work here in New South Wales, and they gave us a good price at tender time, and then backed it up post-tender when we went for our tenders for the demolition of the bridge.
I got a call one afternoon that a bridge was needed demolishing in Windsor, Richmond, somewhere in New South Wales, and I was quite excited about that. It happened that the tender was closing the next day, which made it a little bit of short notice. But from that point on, the juices started flowing, and we started thinking about the ways of bringing it down and dealing with it. Of course, when we saw it in its physical state, in its own geographic location, brought a few more challenges and a few more ideas to the plate. And they kept developing until we finally came up with the lift and roll process to remove the bridge without craneage and barges, particularly because of the limited access and the rapid river conditions that existed around the Hawkesbury River.
The old bridge was a historic bridge. It had work done to it over the years. I believe it dated back to the 1800s and had been raised once or twice in the interim. It was still subject to flooding at very small sort of flood events.
The columns have been in the water a long time, and so they had a reasonable amount of marine growth on them and rust and what have you. Some of the fractures and breaks in the columns weren't evident. They weren't noted in the reports that we received, and they weren't observed by us on our own inspections. But many of the columns had total circumferential breaks, vertical breaks. So we took the view that we had to build something to keep these things together, otherwise we'd end up with a whole lot of broken column in the water. Working on the Hawkesbury and in that particular environment required significant or very significant attention to detail as regards the environment. When we stopped work of an afternoon, we would place barriers, bunding and geofabric to contain runoff or dust from escaping from the area, to ensure that if there was rain overnight, there'd be no runoff into the river. When we were working on the bridge deck, we had bunding. All the scuppers were closed so that any water on the bridge would run waste back off the bridge. There was a great concern that there would be foreign material enter the waterway, and Giorgio and RMS, the client, who were on site permanently with a number of people observing the works, were constantly concerned about that and reminding us regularly that this was their prime concern. Safety and environment were the big issues on the job.
When we commenced tender review for the demolition subcontract package, we looked at the different methodologies that contractors have put forward. Mainline's was quite attractive. It didn't require large cranes in the water or large barges. It had a smaller barge system, and majority of the works, the demolition works, was then undertaken on land, so there was no requirement to do any catching of materials over water. That was very enticing to us and certainly helped with the engagement of Mainline on this project.
Yeah, on the Mandurah Bridge, they were very innovative, and they offered the same sort of smart innovations to demolish this bridge. Obviously, very sensitive area sitting over the Windsor, over the Hawkesbury River, but also we had a lot of environmental controls, so we obviously couldn't allow anything to go in the river. And we would like to have kept as many barges out of the river as possible. And so Rob came up with a quite innovative way of lifting the bridge and putting on airbags and then dragging it across the river. And also the way he brought down the columns was quite innovative to make sure that they came down in one piece and didn't leave pieces behind in the river. So once again, very innovative with his airbag solution, and that's one of the reasons we selected him.
It's really quite simple because we put a lifting mechanism on a barge. So we bring the lifting mechanism into place and then it locks onto the existing piers. So all the lifting is actually done off the piers. There are 4 jacks or 8 jacks involved, 2 on each leg. So the jacks have a double roll. They lift a lifting frame up that locks onto the piers with finger beams. Then once that's in position, we repin the lifting mechanism to lift a table or a platform with airbags on it so that it lifts the bridge deck off its position into a position above the roadway, and then it's rolled away. The airbags draw all the attention, but it takes the attention away from the real best on ground performer, and that is the cradle, which was able to break the columns below seabed, below riverbed, without having to send divers down to cut them. And the lifting mechanism, the lift and roll jacking system, allowed us to move 120 tonne of concrete and steel from where it was on the river to the shore without cranes and barging. They're the real game players. They're the things that made the play. The airbags were the carrier. It's another truck. That's all it is. They're brilliant in their own right, and they do a great job. But the best on ground was the lifting mechanism. It was just brilliant. It worked well. When you design something from scratch and it works that well, it's a delight. The machine that we built, we call it the AFP because it was an airbag flotation pack. It was a steel frame of about 12 tonne that held the columns together. We chained the columns to this steel frame, which you could call a strongback, I guess. And then we put flotation bags on the front to carry the weight of the pier. And so the pier was removed in one section as opposed to lifting portions of it. Fortunately enough, we didn't lift it because many times you might have been lifting 10 tonne and ended up with 3 on the hook because it could have broken away. Generally speaking, I come up with the initial ideas, and then it requires a fair bit of engineering to make that into a reality. But the simplicity of it is the good thing, and it worked very well. It had plenty of capacity, overcapacity, and it simply raised the bridge deck to a point where it could be rolled along the bridge. And we've used airbags before. There was talk about using train lines and trolleys, but the point loading produced by having rail and trolleys was not a good idea on a pretty fragile bridge. The airbags did the trick because it just spread the load beautifully, and they were so gentle. With our first shift, we were having some trouble with what I could call steering the load to the other end. It was about 120 metres of travel. So the bridge section that we were moving kept edging towards one side of the bridge, and we got to a point we couldn't go much further. So we found that by deflating the bags or a bag and repositioning it like a car, like a steering wheel on a car, and turning the bag, it redirected the load into a central position and sometimes over to the other side, and then we steered it back again. But steering the load was quite amazing. We could move it very quickly from one side to the other or into the middle. The Hawkesbury's a mighty river with the Warragamba Dam just upstream, is Sydney's main water supply. And over a summer, it's often at 30 to 40% capacity. After the fires that made world news last year, the bushland wasn't holding water as much as it did, and the rains we had this year were much heavier. Warragamba Dam was full, and from time to time as the rains came, they were releasing water from the dam. Just before the contract started, there was a major flood, and the river rose 9 metres. Just before we finished the work, there was another flood, and the river rose 12.9 metres. With COVID, I was on the ground at the outset getting the preparatory work done, and there was no opportunity to bring our regular team to New South Wales, so we recruited locally, and we took on barging, craneage, excavation, subcontractors and labour locally, and took them through our processes, and that crew implemented the plan to remove the bridge. It's never as easy with new people, but a credit to them, they got up to speed and got through it. The bridge deck came off beautifully because there was no segmentation. We didn't have to cut it into sections. There was no crane loading on the deck. There was no craneage on barges on water. And we got the bridge deck to shore in one piece because in itself, there was a lot of bits that could have fell into the water during the process. So our process eliminated a lot of that. And I think that sold our methodology significantly ahead of the alternatives. We had a great team. We had Jim Vandermeer working from Peritas. We had AJ Malloy working with us on the eastern seaboard, and David Race joined the team over there as well. A lot of people were involved in making that a very workable process. I think it comes down to Mainline has always had a view to be innovative, to find a better way of doing demolition that's safer and better. And in this particular instance, the lift and roll technology that we developed certainly did that, certainly met all the boxes that we feel can be used on many projects.